Welcome back, students. In this class we continue the chapter polynomial, chapter 9, exercise 9.2. Here in this class we continue the question 2. So question 2 is, find a quadratic polynomial each with a given number as the sum and the product of its zeros respectively. So we'll start the problem directly. So what are the given data? That is 1, 4 and -1 is given. So sum of the zeros is given, that is 1 by 4, and product of the zeros is given -1, and we have to find out the required quadratic polynomial. So what are the given data? We'll just write sum of zeros is equal to 1 by 4 is given. Then product of zeros is -1. So now we have the formula to find the is equal to, this is x square minus sum of zeros to find a quadratic polynomial. And x square means sum of the zeros into x plus product of zeros, then close the bracket. After this we have to substitute the values. So x square keep as it is, then sum of the zeros is given as 1 by 4 in x is there, then plus, that is -1 is the product of the zero. Now simplify, cross multiply this, x into 4, 4x square, here minus x, here -4, multiply this, then 4 is the LCM. After this, if we put this constant is equal to 4, then substitute here in the equation, then we get 4 x square minus x minus 4 by 4, cancel this. So finally we conclude, if this is equal to 4, then this constant is equal to 4, then the required quadratic polynomial is 4x square minus x minus 4. Is the required quadratic polynomial. So this is the first one. We move on to the next one. The next one is sum of the zeros is given, and product of the zeros is also given. So what are the given? Given is sum of zeros is equal to root 2, then product of zeros is equal to 1 by 3. So next, substitute in the formula x square minus sum of zeros x plus product of zeros then substitute the values x square then minus root 2 x plus product of zeros is 1 by 3. Now cross multiply this, then 3x square, then multiply this by this by this, 3 root 2x plus 1 by 3. 3 is the LCM. Now what we have to do, substituting this k, substitute this k is equal to 3 in the above equation. Now substitute 3x cube minus 3 root 2x plus 1 divide by 3. Then this and this cancels. Finally 3x, sorry this is square, written square, minus 3 root 2 x plus 1. So if final conclusion, if is equal to 3, then the required quadratic polynomial is 3x square minus 3 root 2x plus 1. So we move to the next one, that is the third. Third, they have given sum of zeros as 0, sum of zeros is equal to 0, product of zeros is equal to root 5. Then the formula will be, substitute here x square minus sum of zeros, then x plus product of zeros. Then substitute the values, x square plus minus 0 is given as sum of zeros plus, then product of zeros is root 5. Therefore x square, this is 0 plus root 5 we are getting. So now what we do, we substitute this constant is equal to 1 in the above equation. Then we get x square plus root 5. Then if is equal to 1, then the required quadratic polynomial is x square plus root 5. This is the third one. We move on to the next, that is fourth one. So fourth one is sum of zeros is equal to 1, product of zeros equal to 1. Then substitute in the equation is equal to x square minus sum of zeros plus product of zeros, sum of zeros and product of zeros. Then x square, substitute 1 into x plus 1, then we get x square minus x plus 1, then substitute constant equal to 1 is a 1 into x square minus x plus 1. Now if we get x square minus x plus 1, if k is equal to 1, then the required quadratic polynomial is x square minus x plus 1. So we move on to the fifth one. Now fifth one, they are given minus 1 by 4 and plus 1 by 4. Therefore sum of zeros is given as 1 minus 1 by 4, then product of zeros is equal to 1 by 4. Then substitute in the, that is x square minus sum of zeros, sum of zeros into x plus product of zeros. Now substitute the values, x square minus 1 by 4 into x plus 1 by 4. Now simplify this. So what we get, so take LCM. So we get 4 multiply 4, x square minus, then this will becomes plus into x plus then this is 1, take LCM, this is 4. Now substitute k is equal to 4, then we have 4 into 4x square plus x plus 1 by 4. Cancel this, we get 4x square plus x plus 1. If 4, then the required quadratic polynomial is 4x square plus x plus 1. This completes the fifth one. Now we move to the sixth problem. Sixth problem given as sum of zeros is 4 and product of zeros is 1. Sum of zeros equal to 4, product of zeros is equal to 1. Then substitute in the formula is equal to x square minus sum of zeros into x plus product of zeros x square minus, substitute the values 4x plus 1. Now substitute is equal to 1, then we get 1 into x square plus 4x plus 1. Finally we get x square minus 4x plus 1. So now what is the conclusion? If k is equal to 1, then the required quadratic polynomial is x square minus 4x plus 1. So this is the solution for sixth problem. So we completed this question, that is second questions completely, that is which consists of 6 problems. So this completes the exercise 9.2. So we'll start with a new exercise in the next class. If you have any doubt, comment me, subscribe my channel, share and like all the videos. Thank you.